Hey, my name's Charles with clectric-diy. Welcome to part 3 of the SoundHound Circuit Bin series. There will be a part 4 because I am interested in learning more about the couple things that I have been working on. It has been months in my time stream since part 2 happened. You might be watching them back to back, but it's been a while. This thing's been sitting on the shelf. Honestly, I wasn't super inspired by it back then, but I deliberately put it up someplace where I looked at it every time I walked past and got curious about it again, so I picked it back up and found some fun stuff. I was being lazy last time is really, the bottom line. Anyway, let's switch over to the Workbench and check out what we've got going on. So our good buddy the SoundHound is here. So 2 things that I've added and then 1 thing that I'm working on. So the thing that I had wanted to do really since I set it down was a voltage starve. This is a common circuit bending technique. Basically what I have done is I've wired a potentiometer. This is a linear 1K, B1K, 1000 potentiometer, wired it in line with the power. And what this does is it simulates the device running out of batteries. Oh, he's going to sleep. Simulates the device running out of batteries. So when I wake him back up, let me describe what I got on the bench first of all. So I have added a 1/4-inch jack, nope, 1/8-inch jack to this, so like a guitar jack, so that when I continue to bend this thing I can plug it into a guitar amp, just like this mini amp that I have here sitting on my desk. If you buy one, make sure that the one you get goes to 11. That's really important. Then I've got oscilloscope set up over here, so these, it's all plugged in the same place. I've just got so that you can both see the waves and hear the waves when we play them. So the other thing that I've done in part 2, use that one to see a close-up of this circuit board, and I talk a lot more about what's on it. But during part 2 of the video and in other experiments that I've done since, I learned that if you probe from this point right here, it's just above resistor 1, sorry. If you probe just above resistor 1 to either this spot, which is this white cable coming off of the board, or this spot, which is part of the, there's a daughter board, basically an integrated circuit that they've got soldered in. If you probe from here to here or from here to there, it has 2 different tones that it makes. And in fact, they're 2 different oscillations. And we'll get into that here in just a second. The thing that I've done is I've wired onto this board those 2 points that I was talking about, and then I actually went down to the volume knob. It turns out that is part of the volume adjustment. So what I believe this is doing is actually just creating a feedback loop to get those tones. So we'll play with those here in a minute, but first I want to show you the voltage starve. Let me turn this all the way down. So I'm turning this just really slowly. And there comes a part where he's going to give up and just give us a bark. So right there, so that's the point, and it's about 50%, I think, on the turn. That's the point where the board is basically saying, I don't have enough juice to do what I need to do. I'm going to give up. It seems like that's what it's doing, because then if you turn it back up, it doesn't come back alive right away. However, if you continue to turn it past that point, you start getting this oscillation. And oscillations are really, really good news in the world of circuit bending. So everything above that sort of bark point is something that, I mean, they might both help you, but something that definitely helps you with the circuit bend as far as the sound that the thing's making. And then you get down to this point and you start making new sounds. So let me show you something that I've found that we can do with those new sounds. So what I'm going to do is I'm going to bridge this blue cable is that just above resistor 2 that I talked about earlier, and I'm going to bridge that with this green cable. So that's coming off of the IC. That's what's got all of the, or the daughter board. It's what's got all of the sounds on it. So I'm going to bridge those two. So, if you look at the oscilloscope, it's got a pulse wave, or a a square wave, and then in the middle of that square wave, at the trough of it at the bottom, it's got, I don't know what's going on because I've never seen that. It's a some kind of a modulation or modulation within it. So now, continuing with that voltage starve change, it's adjusting the pulse width. So we have a frequency adjustment. And then we get to that point. So basically, you know, you're clicking right in here. So that's a pulse width adjustment up until you get to that point. So what's interesting about when you get to that point, so that's, it just happened to be, that's probably as wide as that can be. Just happened to catch it. Turned it just a little bit further. Watch what we're looking at now. So we have a good solid square wave. With a frequency adjustment. You can see it always, it's always the most fun when you find that little spot in the middle. Let's see what that looks like if I even it out. So we got kind of a wobbly square there, and then it does this weird thing where it rounds off the tops like that. I don't know how to describe that wave. But we have a frequency adjustment on the sound down, which is pretty neat. I need to look it up because I actually don't know what it's called when it changes both in the frequency, wide is the frequency adjustment. It's actually moving up and down as well. There's a name for it, I'm sure. But it's not amplitude, or else it'll be getting bigger on both sides of it. So I'll look that up and figure out what that is. But yes, so we've got both a wave adjustment and frequency adjustment in the Soundhound now, which is pretty cool. So okay, so then that was all on this green cable, which is coming off of the daughter board that has the guitar sounds and dog sounds and that sort of thing. On the other cable, which I haven't even traced that, honestly, to tell you what it is, which is the fun of circuit bending. You just kind of watch and see what it does. So let me start with that unplugged. Let's get back to the state where we knew where we were. So here we are in regular mode. Then I'm going to bring it down just past that bark that I described. So now we're in the mode where we have that oscillation, and instead of connecting the green wire, I'm going to connect the white wire, and it makes a god-awful noise. And it's not as interesting or predictable yet, as far as, yeah, the other one, it was kind of a little easier to tell what it was doing, but obviously that's an interesting oscillation. It looks like it's doing the same sort of, I can control the pulse width between the two, and once it goes into that, if I adjust the domain again, so this one's doing stuff. It might actually end up being more interesting. Don't know for sure, but just wanted to kind of show you that. I did forget to mention one thing. Let's find this oscillation. So I switched back to the green wire. Sorry, I didn't mention that as I did it. So now we're back to this square wave. Because it's connected to that volume knob, the volume knob also has an effect. Volume knob changes amplitude, which is what you'd expect. Moves it up and down. So maybe it's not having as much of an expected. Yeah, it might just be adjusting the amplitude or the size of wave, which is what the volume is, right? Ah, that is interesting, actually, that it's picking up the bottom of the wave, so the top of the wave is staying high, the bottom of the wave is going up and down, and then you reach the bottom point here and it pulls the top of the wave down. So, like I said, that modulation, I'm not sure what that's called when the whole wave moves up and down, like that right there. Not entirely sure what that's called, but I'll look that up and try to have it. Anyway, so that is enough of that racket for the moment. But part 3 of the Soundhound circuit bend, and look forward to part 4. I'm going to mess with that a little bit more and see what we can get it to do, but just having any sort of pitch variation is a really big deal when it comes to circuit bending. So check out parts 1, 2, and 3, and hopefully part 4 will be out by the time the algorithm finds this the algorithm makes this video find its way to you. I'm Charles. Take care.